is CPU cache. Now a computer has two different types of memory. One type is that what use a RAM module, which is DRAM or a dynamic RAM. And DRAM is memory that uses capacitor to store data, and the capacitor has to constantly and dynamically to be refreshed, often with electricity, in order to store data. But there another type of memory that computer uses that doesn't have to be constantly refreshed, and this memory is called SRAM or static RAM. And static RAM is what used in CPU cache, and because SRAM doesn't have to be constantly refreshed, it is a lot faster than DRAM and is also very expensive. The CPU cache is CPU's internal memory, and itself is for copies of data and instruction from RAM just waiting to be used by a CPU. So basically, what CPU cache does is that this whole common data it thinks CPU is going to access over and over again, because when CPU needs to access certain data, it always takes the faster cache memory first to see if the data is there, and if it's not, then the CPU will have to go to path to slower primary memory or RAM to get the data it needs. So that's why cache memory is so important, because the CPU can access what it needs on the faster cache than the faster computer will perform. So basically, the whole idea behind cache is to make computer run faster at cheaper price. Now, a computer can run without the CPU cache, but it would be a lot slower, because even though RAM is becoming faster, it still can't fit the data CPU fast enough, because CPU have gotten so fast that a lot of time the CPU is waiting around doing nothing while it waits for more data. And this creates bottleneck. So that's why CPU cache was developed. So it can act like middleman between the CPU and RAM to assist and feeding the CPU that data it needs a lot faster, which reduce bottleneck. CPU cache come in different level. For example, there's level 1 cache, which is called primary cache, and level 1 cache is located on the processor itself. So it runs the same as speed as processor. So it's very fast and faster cache on the computer. And there is also level 2 cache, which is also called external cache, and level 2 cache recent data access from the processor were not cached by level 1 cache. So in a nutshell, if the CPU can't run such the data it needs, it's a level 1 cache. It then sets the level 2 cache for the data, and if CPU can't find the data in the level 2 cache, then it caches for the last level of cache, which is level 3. And level 3 cache is used to cache recent data access, they are not cached by level 2 cache. And finally, if level 2 cache 3 doesn't have data, then the CPU has to go back to slower RAM to find data it needs. Now, in earlier computer, level 2 cache was located on separate chip. On the modern CPU, it could be located on the processor. Level 2 cache is larger than level 1 cache, but it's not slow as level 1 cache. And level 3 cache is also located on the processor. Level 3 is larger than level 2, but it's not fast as level 2 cache. Level 3 is often referred as shared cache because its memory is shared between on-core CPU, whereas level 1 and level 2 cache are the same to their own CPU core. And, and the processor is connected to the memory with a head of system bus. So with respect to this core, if you observe closely, the L1 and L2 cache for each of the core are the private storage, whereas the L2 caches and the main memory as shared storage. So basically, it's a multiple processor system. Every core has its own independent memory storage. Also, there are some memory storage which are shared among them. Now, consider this organization where we have four different processors named B1, B2, B3, and B4. And all these processors have their own private caches. Also, we're considering all of the processor have only one single private cache. Now, as a shared storage, we are considering the main memory, which is connected to the organization, the head of system bus. Additionally, all the different private caches were interconnected with the head of the original bus. Beside the main memory, we have program code, which has the global variable A, and that has initialized to 7. Consider the situation inside an organization with as an ISD is portable instruction stream and single data stream organization. That means on the different processor, we operate on the same data. That is A. Now suppose the processor P1 wants to perform the operation S plus 1. That means it wants to increment the value of A by 1. Now in order to do so, it will first go ahead and look for the value of A inside on graphic cache. However, since it's very first access to it, the result come from S, meaning P1 doesn't have the value of A itself or graphic cache yet. Therefore, if we go to the next level of the memory hierarchy, it's memory bring the level A from there is taking on graphic cache. Now, once we have the value of 8 inside B on graphic cache, now you can go ahead and perform operation wanted to be performed. That means now we increment the value of 8 by 1 as 8. Also, we to perform operation 8 as 2. Value is by 2. However, since it doesn't have the value of 8 present inside its own private cache, yet therefore it will go ahead and move the globe A from the main memory to its own private cache. Now once we have the value A present inside its own private cache, we can now go ahead and perform operation which we want to perform. That means now we can increment the value 8 by 2 and 8 as 9. Similarly, suppose you want to increment the value of A1, therefore, if we write and look for the value of inside the main memory, bring the value of A from there, take all private cache, Once it has developed 8 inside its own private cache, it can declare develop 8 by 1, making it 6. And finally, suppose before or to request develop 8 or 2, if we follow the same rule, that means we bring develop 8 from the memory inside its own private cache, and once it has done so, we can now go ahead and update the volume of 8 as 5. Now, if you observe carefully, the same value variable A has different value in different private caches. Now, this is constant, and this particular constant will refer to as cache coherence problem. So basically, what is cache coherence problem? It's a uniform of shared resources data that has also multiple global caches. That means you need to maintain uniform, and that is exactly caching coherence. Now, coming to caching coherence problems, choosing or keeping multiple caches right, one of the potential of days is only operator we can share among multiple caches. That basically means if we have a share value integral for the caches, they need to be synchronized. So the thing is skipping the synchronized. That is basically the cache coherence problem. Now, as a solution, this cache coherence problem, we have both system protocol. Now, before getting directly to the protocol, let's talk about some associated terminology. So we have dealing with the caches where we already know every cache is logically divided into line of blocks. Now, in order to ensure currency, we maintain some information within the cache controller. And what's the information what we maintain for? For every cache block, we specify some space. One of the space is modified. So when we specify that particular line is modified state, it means that particular line contain data modified based on register. This is constantly with the main memory. Now coming to the next slide, that is sphere. So when we specify multiple line is sphere space, it means that line contain unmodified data and thus can appear in at least one of the CPU caches. However, remember, in a memory block where multiple CPU caches, it only share state. Now, the next state is invalid. This means that the line data has invalid because some other requester wrote to the cache relating to the which also share a particular line. Now, basically, when we first start, we have some nice first memory to our own project caches. The state of that particular cache line is set to share. Now, it's in our project that decide to update a particular line content in the case the state of particular line we proceed to modify. However, if some other processor was operating on the same data, modifies the content prior to our user. In that case, we are to ensure the currency inside of that particular line inside our code cache to share to invalid. Apart from this, we will specify some other state of particular cache line and we use it on and forward. As I say, exclusive means that the cache is present only current cache and not the memory. That is, it may be changed, share state at any time. This is to request from any authorized processor. If the state of a particular cache lies is by its own, it means that the cache is so of content and be responsible for specifying the risk request by also auto processor. Now coming to the forward state, it is specialized for the share state. Finally, if the memory block contains multiple caches, and then after terminating the forward state, in that case, the memory also update the cache state. We be responsible for coding the operation smarter the cache. For the archetype, which can be specified for the particular cache line, depending upon the protocol that we follow. Now let's take different cache policy protocols. Now, as a student to cache problem, there exists the full-time-based cache a key machine, right? So they also compiler of the operating system. Basically, compiler has core mechanism to analyze all the code to determine what is better automatic unsafe for caching. The operating system prevent those data from being cached during runtime. Otherwise, they are called cache cross scheme, not protocol. The hardware-based solution also referred to as cache cross protocol. Since we are in this course, we mainly focus on hardware-based solution. Additionally, the cache currency protocol demonstrates improved performance of the cache currency schemes. Two types of cache currency protocol. First one is called flipping or first phase protocol. As mentioned, with cache the domain something for the first when I'm on time. That means whenever any person generate the broadcast request over the set first on the cache controller using on the first and calling my their own caches. Now running the approach of snooping based protocol. First one is called write update. The second one is called write invalidate. Write text wash. The cache line gets promoted from share to modify state. In that scenario, all the caches requesting same content will update button. Whereas in case of write invalid, such scenario also for consistency content to ability to order of copies. Now during the session of overview text design, we came across different class services. So this approach can be referred simplified into two more categories based on the right salary that implement. That means the right price can be implemented using the right strategy, right best strategy. And the same can be said for data as well. This process looking at protocol, right? Right path, right to, right back. Now the next time hash conflict protocol is called directly based protocol. Here, visualize objects maintain each track of the data items. Along with that, every processor perfect directives also maintained to help achieving currency. The main difference between snooping and regularly based protocol is looping or snip based protocol. Broadcast messages are used, and the cache are collected through the bus, whereas in directly based protocol, the nodes are collected using a scalable data mesh network, implementing point-to-point communication. So these are basic online concept of the tools protocol. Always remember that cache as a hardware-based solution to catch the coherence problem.